This is your key to the period 1 test. First question, identify the common difference or the common ratio. If I look to see if there's a ratio, 36 divided by 27, is that the same as 45 divided by 36? I can tell right away that those ratios are different, so it's not geometric. If it's arithmetic, there's a common difference. 36 subtract 27 is 9, 45 subtract 36 is 9, 54 subtract 45 is 9. There's my common difference. My D equals 9 or positive 9, and I know that this is arithmetic. So I need to write the recursive formula. Recursive formula starts off with A or U sub 1 equals my first term. There's a sub 1, my first term is 27. If this were an A sub 0, that would imply that 27 is the y-intercept, or the 0th term, the starting value. But in terms of just sequences, we don't really talk about y-intercepts. It's just a sequence, it's not graphed. And we don't know if that's the actual y-intercept or not. It's just the first term in the sequence. So it's sufficient just to say A sub 1 versus define it any other way. So the first term is 27. The next term is equal to the term that came before, A sub n minus 1. Be careful that this subtract 1 is no larger than the n. I know some of your papers had this as a to the nth. Subtract 1. Keep that as part of the subscript, please. So every subsequent term is equal to the term before plus 9. That's not part of the subscript. This is part of the subscript. Where n is greater than or equal to 2. It is okay to have defined the general term before the start of the first term. So this could come after that part. You could eliminate this kind of obvious that we're going to start with 1 and then every subsequent n will be a 2 or larger. But again, this is just convention. You'll see it different ways depending on if it's a test or a different textbook. All right, and then I've already stated whether it's arithmetic or geometric. The second one, it's obvious to me there's not a common ratio. There is a common difference. The difference here looks like it's a negative 10. So it too is arithmetic. And then the recursive formula, we write it the other way this time. I can say U sub n equals the term that came before, subtract 10, and the first term was a negative 25. Arithmetic. Problem 3. I see that the difference changes, so I'm going to look for a ratio. Negative 20 divided by negative 4 is 5. Negative 100 divided by negative 20. So I have a ratio that is equal to 5. So it's geometric. And my recursive formula is my first term is a negative 4. Every other term is equal to the term that comes before multiplied by 5. Or I can say 5 times the term that came before. Either way, again, multiplication and addition is commutative. So it doesn't matter if I put the ratio in front or if I put it after. Where n is greater than or equal to 2. The next one also is geometric. 6 divided by 2 is 3. 18 divided by 6, 54 over 18. Common ratio makes it geometric. Every subsequent term is equal to the term before times 3. And my first term is a 2. How do I find missing terms in a sequence? Well, it clearly states that these are arithmetic sequences. So I'm looking for a common D, a difference. So I have terms that are missing here, but I know that I am adding a D to 23. I'm adding D again to that term. I'm adding D again to that term. And I'm going to have this piece. 23 plus D plus D plus D gets me to 113. So what's my difference? The difference between 113 and 23. The difference between 113 and 23 is 90. So I have 3 D's equals 90. If I solve for D, D must be equal to 30. So my difference is 30. 23 plus 30 is 53. Plus 30 more is 83. I found my missing terms. I have D plus D plus D plus D a fourth time. So 4 times D equals the difference between -1 and -121. The difference is a -20. -21 subtract the opposite of 1 is -120. Divide both sides by 4. My common difference is -30. So -1 subtract 30, subtract 30, subtract 30. You'll be able to find your missing terms. How do we find the missing terms of a geometric sequence? Well, whereas an arithmetic sequence has a common difference, a geometric sequence has a common ratio. So the common ratio is being multiplied, and this is my 3 times my ratio times my ratio a second time to get to 27. Shortcut for repeated multiplication is a power. Now, how do you undo powers? Well, I know that R times R is going to be the ratio of 27 divided by 3, which is 9. To undo a power of 2, I raise to the 1/2 power, or the second root, and my ratio ends up being 3. So 3 times 3 is 9. 9 times 3 is 27. That works. Same process for problem number 8. But in this case, I am multiplying by my ratio, multiply by my ratio, multiply by my ratio, multiply by my ratio, 4th time. R times R times R times R is R to the 4th. To undo a power of 4, I have to find the 4th root. The ratio of 5184 divided by 4 is 1296. Again, the ratio 5184 divided by 4 is 1296. I find the 4th root of both sides, and I get R equals 6. Just to confirm, I want to know, is 6 to the 4th power 1296? And it is. 4 times 6 times 6 times 6 times 6 gives me 5184.